Hey everybody, we're going to do a lesson today for our grade 12s, ostensibly this is for our grade 12s, to review how to factor. Um, so if you're wanting more in-depth practice than this, you can of course go to the school's Weebly page. Here it is right here. And you can look up in your grade 10 where all of the factoring videos are. But there's a lot of videos in here, so I'm just going to quickly go through all of these things with just a few examples from each one. What I handed out is I handed out a couple of things. I handed out, let's see, oh no, that's not what I'm looking for. No, that's not what I'm looking for either. Okay, maybe I don't have what I'm looking for open. Oh, here it is. Here it is. There we go. There. So I handed out this factoring practice after the Chapter 2 test. And here's what I think you should do. Give all this, or as much of this as you can a try. And if 1 to 8 goes easily, but then you get stuck starting at number 9, or you get stuck starting at number 21, or you get stuck starting at number 32, or whatever, you can just go to whatever part of this video kind of covers that. I'm actually going to maybe start at the end. How do you do ones like number 33, say? Well, for these ones, what you're going to do is you're, of course, going to look for the greatest common factor that you can find in there. So the greatest common factor, I noticed that all three of these terms have a -2 in them. So I'm going to take out -2. And then this has an x cubed, this has an x squared, and this has an x cubed. So they can all give me an x squared. This one has a y, this one has a y to the 5, this one has a y. They can all give me a y. And then I open the brackets, and now, once I've factored this factor out of here, what's left behind? Or another way to think about it is, what would I have to multiply in this bracket to get this expression back again? So once I've factored out -2, x squared, and y, all that's left of the first term is an x. All that's left of the second term is a -3, and then a, let's see, we have the x squared, so there'd be 4 more y's need to be there, so y to the 4. And all that's left in the last term would be a +5 and then an x. And then I notice actually that I have myself a couple of like terms here. I can actually combine them. And I'd have x plus 5x is 6x minus 3y to the 4. And there we go. There's my final answer for the first one. Notice I could have collected these like terms before I did my factoring, but I don't know if I noticed right away that they both had common like terms to them. So you do 34, 35, and 36 the same way. You try to find your greatest common factor and you factor it out. So if those were the ones you were stuck on, that's called just factoring by greatest common factor, and you do it the way I just showed you. The rest of these things in this practice booklet are trinomials, and we handed out today a little notes booklet that I told people is optional. If you're struggling with this and you want to see some examples, take out this booklet and let's run through some examples of each type. All right, so let's start going through some examples here. So the first thing we do is we look at just a basic trinomial where notice that the a value, the number in front of x squared, is a 1. So if we have a 1 there, we basically just ask ourselves what two numbers multiply to make 20 and add to make 9. So basically, what two numbers multiply to produce C and add to make B. So C and B. So let's do that for this first couple of examples here. Feel free to pause the video and try it yourself if you want to try it yourself before I give you the answer, and you can of course do that for all of these going forward. So let's see. What two numbers times to make 20 and add to make 9? Well, if I want to break down 20 into its factors, I know it's 1 and 20. That's too far apart to add up to make 9. 2 and 10, still too far apart. 4, and 5. And there's my winner. 4 plus 5 is 9. So this thing factors to x plus 4 times x plus 5. All right, so that's how these ones work. If you want to try the next couple yourselves, please do. Pause the video and give it a try. All right, if you've tried it, here's how I would do it. What two numbers times to make 7 but add to make -8? And notice if they multiply to make a positive but they add to make a negative, I know right away that both of these factors have to be minus. Right? You can't multiply two negatives and get a negative, and you can't add two positives and get a negative. So I know it has to be minus minus. And 7 only has one way that it factors, 7 and 1. 7 times 1 is 7. 7 plus 1 is 8. Okay? By the same logic, I know this one has to be a positive and a negative. How do I know that? Well, they multiply to make -8. So what two numbers times to make -8 but add to make -2? Well, when you add a positive to a negative, of course, you think of that as subtracting. And -8 you could get by going -4 and +2, or you could go +4 and -2 when you multiply. And I know it has to be this one, because notice they add up to make a -2. So I know that the 4 has to be the positive and the 2 has to be the minus. So 4, oh, wait a minute, other way around. Yeah, that's what I said. The 4 has to be the, sorry, let me say that again. The 4 has to be the negative, the 2 has to be the positive. So the 4 goes here. Oops, now my pen's dying. 2 goes there. There we go. So there we go. That's your basic kind of factoring. Some textbooks have a name for this. They call it factoring by inspection. You just look at it and inspect the number involved, the two numbers, and come up with the answer. Now, when A isn't 1, the first thing you do is you take a look and see, well, can I factor a 2 out of all three of those numbers? Well, not without going into fractions and decimals, and we don't want to do that. So now we do something called factoring by decomposition. And the way that works is, let me just explain to you why this works. If I had something like, say, 2x plus 3 times, oh, I don't know, 3x minus 1. If I multiplied that out, I'd get 6x squared, right, first times first. Outside times outside, it'd be minus 2x. Inside times inside, it'd be plus 9x. And 3 times -1 is -3. And then here's what you maybe never noticed about this. Your next step is, of course, to just collect the like terms and say you're done. There, I've got a trinomial now. But backing up to when it was 4 terms, maybe you never noticed this before, but notice that 6 times -3 is -18, and -2 times 9 is also -18. Now, why is that important? Because that allows me to think about this backwards. Instead of, if I want to factor this thing, I can decompose this 7 back into -2 and 9. Now, how did I know to do that? Well, I said, well, 6 times -3 is -18, and I said, what two numbers multiply to make -18? But when I add them, I get +7, and I'd get 9 and -2 very quickly. Now, what do I do when I'm here? To get back to the things I started with, the factors, I actually just factor these two parts separately by common factor. So I factor out a 2x out of these two guys, leaving me 3x minus 1. I factor a 3 out of these two guys, leaving me 3x minus 1. And if you're doing this right, these two brackets should be the same thing. I can factor it out. Think of it, if you like, as 2x times z plus 3z. And somebody said, factor that. Oh, you just factor out the z, and it'd be 2x plus 3. Well, my z in this case is this bracket, 3x minus 1. So I factor out 3x minus 1, and there we go. I'm back to where we started. So this is the method we call the decomposition method. It's basically the opposite operation of multiplying out two binomials. So let's try that on these examples. All right, 2 times 5 is 10. What two numbers times to make 10 and add to make 7? Well, it's obviously 5 and 2. So this is going to be 2x squared. I'll say plus 5x plus 2x plus 5. What can I factor out of the first two things? I can factor out an x. And what can I factor out of the next two things? Well, you might say, well, you can't factor out anything. Well, then we'll just factor out a 1. And now we factor the bracket out. And what's left behind when I factor out that bracket? Well, there'd be an x left behind and a 1 left behind. And there, now we are factored. Try that again for example 4. Pause the video, give it a shot. All right, how did that go? 5 times 2 is again 10, but this time the two numbers that times to make 10 and add to make 11 aren't 5 and 2, obviously, they're 10 and 1. So this is going to be 5x squared plus 10x plus 1x plus 2. I'm going to factor a 5x out of the first two things, leaving me x plus 2. And there's nothing I can factor out of there, so again, I just say factor out a 1. And once I've done that, I can now factor out the x plus 2. And there it is, factored. So that's the decomposition method. Give it another try here. And on number 5, pause the video, give it a try. All right, how did that one go? 3 times negative 10 is negative 30. What two numbers times to make negative 30 and add to make negative 13? You might be thinking, oh, well, isn't it 3 and 10? No, 3 and 10 doesn't work because negative 3 and positive 10 don't add to make negative 13. Positive 3 and negative 10 don't add to make negative 13. It must be something else. How about we try negative 30 and negative 15 and 2? Those are my winners. They add up to negative 13. So I'm going to decompose negative 13. Turned out kind of ugly. I'm going to decompose negative 13 into negative 15x and plus 2x. And now I'm going to factor out 3x. And I'm going to factor out a 2. And then I'm going to factor out the x minus 5. And we call this the decomposition method. There are other ways and other methods to do this type of factoring, but quite frankly, I don't like them. What I like about this factoring by decomposition is that it gives you this kind of overarching kind of skill of being able to look at a bunch of factors and say, aha, I can factor something out of these two, I can factor something out of those two. It just improves your overall general factoring skills. It helps you recognize when you can factor and when you can't. And factoring gets a lot more complicated as you get into things like calculus. So the little shortcut method that some people write where they just, I don't even know how they do it. They put the 3 here and the negative 10 here, and I don't even remember how they do it. But it doesn't really lend you to being able to look at a piece of algebra and go, okay, what can I factor out of this? So I like the decomposition method, and that's kind of the only method I tend to tell my students that I would recommend. All right, try example 6. Now I'm going to give you a hint on example 6. Don't forget that your first rule is always look for a common factor. So give that one a try. All right, how'd it go? Did you notice that you can take out a 2? And then that one you can factor by inspection. What two numbers times to make 6 but add to make negative 5? Negative 3 and negative 2. Let's try example 7 the same way. Again, pause it if you're not sure, and then give it a try. Okay, how did that go? Factor out a negative 3. Careful, if you factor a negative out of a negative, it leaves you with a positive, and if you factor a negative out of a positive, it leaves you with a negative. And the two numbers that multiply to make negative 4 but add to make positive 3 have to be plus 4 and minus 1. So there you go. That takes us to what happens if we're factoring a squared plus bx plus c and c is 0. If that's the case, you will always have a common factor of x. You can always take out at least x. I should maybe say a common factor of at least x. And in this case, I can take out a negative 2 and an x, which leaves behind x plus 4. Factored. Let's try this one. I can take out, well, 3 and 10 don't have any common factors, but I can take out x, leaving me 3x minus 10. Done. Factored. Okay. What if the b value is 0 in ax squared plus bx plus c? Well, if the b is 0, then this doesn't exist at all, and you can treat it like it's a difference of squares. If it's a difference. X squared minus 9, you could think of as x squared plus 0x minus 9, and then you treat it the same way you've been treating all of the trinomials by inspection. What two numbers times to make negative 9, but add to make 0? And that's x plus 3, x minus 3. For example 11, notice that you can factor out a negative 3 first, and then once again you have this two perfect squares, and you again call this factoring a difference of squares. Why is it called a difference of squares? Because That's a perfect square, and that's a perfect square. That's a perfect square, that's a perfect square. And difference just means subtract. So this becomes negative 3 times x plus 2 times x minus 2. So that's factoring a difference of squares. By the way, this has a name too. These two partners here, these two factors here, are also called, they're called conjugate, I don't know if I'm spelling this right. I think so. Conjugate pairs. I always like the rhyme on this. Conjugate pairs, difference of squares. It's very Dr. Seuss. That's always amused me. All right, you might be looking at this going, hey, 2's not a perfect square, and you're right. But you know what you could do? Is you could pretend it's a perfect square and do that. Neat. All right, next for trinomials, we can do a shortcut. If you can recognize that your trinomial is a perfect square trinomial, then you can just immediately factor it into this form here, where you have the square root of a times x plus the square root of c all squared. Here's what I mean by that. You can recognize right away that 16 is a perfect square, and you can say that that's x minus 4 squared. Don't believe me? Try multiplying it out. X minus 4 times x minus 4 is x squared minus 8x plus 16, right? First times first is here. Outside times outside is minus 4x. Inside times inside is minus 4x. That adds to minus 8x. And 4 times 4 is 16. Now, how do I recognize that this is a perfect square trinomial and that I can do this? Well, you recognize it by noticing that the middle term's coefficient, negative 8 here in this case, is 2 times the square root of the other two coefficients, or the coefficient and the constant, I should say, multiplied together. So a here is 1. That's a 1. And c is 16. 1 times 16, square rooted. Maybe I should square them first. The square root of 1 is 1. The square root of 16 is 4. 1 times 4 doubled is 8. That's how I knew it's a perfect square trinomial. Let's see if we can do this one. The square root of 4x squared is 2x. The square root of 9 is 3. If I times those together, I get 6x. If I double that, I get 12. That's supposed to be a 2. There we go. So that's how I notice, yep, that's a perfect square trinomial. So I can just shortcut it to that. And this one, think about this. The square root of 1 is 1. The square root of 3 is root 3. And if I double that, I get 2 root 3. And that's what I have in the middle here. So this is x minus root 3 all squared. And there we go. That takes us to the end of our quick little refresher on how to factor trinomials. I highly recommend, if you're not strong at this, that you take some time and and you go to the page I handed you after you were done the Chapter 2 test and see how many of these you can get. The answer key is on the blog. Good luck, and if you have any other questions about factoring, come and see me when you can. Bye-bye.